This video covers question 6, part B of the 2022 AP Calculus AB free response section, no calculator allowed portion. Part B here really has two pieces to it. The first thing they want us to do is find the acceleration of particle Q. And then the second part of this is going to ask us to find all the times when the speed of particle Q is decreasing. So we really have two questions in part B, and we'll take on the first part about finding that acceleration. So to find acceleration, we want to remind ourselves of our physics relationship. So when we talk through these physics relationships, if the original function is the position function, then the derivative of position is the velocity function. And then the derivative of velocity, the second derivative of position, is our acceleration. And so on this problem, we're talking about particle Q. So again, be careful on this type of problem where we've got two particles happening here. So this one wants to talk to us about particle Q's acceleration. And we see that what they've started us off with particle Q is they've started us off with a velocity equation. So we're actually at this middle level right now to start with. And in order to find the acceleration equation, we're just going to need to take the derivative. We need to move down a layer. So we're going to need to take the derivative of our velocity equation that they give us right here. So we'll start this problem off by taking the derivative of this velocity equation. So 1 over t squared. The first thing we need to do is we've always got to be on the lookout for a handful of algebraic rewrites that we need to do before we take a derivative. This one here is the rewrite. Whenever you have a number over x to a power, you want to rewrite that by bringing the x up from the bottom to the top and making that power negative. So if you had something like 5 over x to the third, you'd want to rewrite that as 5x to the negative 3. So on this problem, we're going to go ahead and rewrite this. We're going to bring this t squared from the bottom to the top. This would be 1 and then t to the negative 2. So that's just a rewrite only to get from there to there. Now that we've done the rewrite, now we're ready to go ahead and find our derivative. So this is just going to be a power rule here. So the power rule saying just says bring the power down, at least my power rule saying. My power rule saying goes bring the power down. And then step 2 of the process is subtract 1 from the power. So doing that on this problem, we would bring the power down and bring the negative 2 down. Negative 2 times 1 gets me negative 2. Subtracting 1 from the power, negative 2 minus 1 gets us negative 3. And then at the end of this, you basically would kind of want to undo the rewrite. If you notice that we've got that negative exponent there, you're basically starting here on the rewrite, and you want to undo it and put that back down to the bottom here. So our v prime of q of t, which would also be the acceleration, so a sub q of t, is really equal to negative 2 over t to the third. So we're just going to undo the rewrite and put that back down to the bottom. And so there we have our a sub q of t, our acceleration for the particle. Now the second part of this wants us to come through and start talking about the speed of the particle is decreasing. The key word on this is the word speed here. When we're talking speed, we're actually talking about the absolute value of velocity. And so when they talk to us about things, the speed increasing and the speed decreasing, it's different than if they asked you about where the velocity is increasing or the velocity is decreasing. The speed is going to be increasing whenever our velocity and accelerations have the same sign. So if velocity is positive and acceleration is positive, then we're talking about this thing speeding up. It's also true, though, if our velocity was going negative and our acceleration was going negative, that would also tell us that this is increasing our speed. So any of those two things mean we're increasing the speed. This problem wants us to talk about when we would be decreasing the speed. Well, decreasing the speed is going to happen whenever your velocity and acceleration have different signs. So if the velocity is positive and the acceleration is negative, then we're decreasing our speed. And also the other way around, if our velocity is negative and our acceleration is positive, then we are decreasing our speed. And so on this problem here, we're on the lookout for this second part. We want to know, when is this going to be decreasing? So we want to know, when does our velocity and acceleration, when do they have different signs? So let's come up and let's kind of look at what our two formulas are right now. So we've got our velocity equation. V of q is 1 over t squared. And then we've got our acceleration equation that we just created ourselves, and that's going to be negative 2 over t to the third. Normally on one of these problems, what you would want to do is, find your critical values, find your possible inflection points, do sort of a number line, first derivative, second derivative game. However, in this problem here, there's really only one place where you would have a possible critical value or a possible inflection point, and that's when the bottom of these fractions is equal to 0. So at t equals 0, that would be our only critical value, because we're talking first derivative, remember when we're talking velocity, and t equals 0 on this side would be our only possible inflection point. But you'll notice that they tell us that t is greater than 0 always. So these two things aren't even going to matter here. And so what we know is whatever is happening beyond 0, if we think about it in terms of a number line here, 0 would have been our critical value or our inflection point, but because it's starting out being greater than 0, that was our domain, we know that it never changes over this entire process. So what we want to do is let's figure out, we really only have one option. It's either always going to be decreasing because it's always going to do this, or we're going to end up finding out that it's always increasing. So choose a test value out here. Right? This is like a first derivative test, second derivative test. I'm going to choose a test value, t equals 1, because it's an easy number to plug in when I don't have a calculator, right? So if I do v of q of 1, plugging 1 into that equation, I would get 1 over 1 squared, that's 1. So I'm going to put my velocity up on top here, is always positive because there's no place where it's going to change. So the velocity is positive. And now if I go look at my acceleration and play the same game, choosing that same test value because it's an easy number to plug in, then on this side I get negative 2 over 1 to the third. And so out of there I'm going to end up with a negative 2. And because it doesn't change, I know that my acceleration on the bottom here is always negative. And so what we can see now is that because it doesn't change, and because these are now opposite, I've got a positive velocity and a negative acceleration always, I know that this thing is always decreasing across this entire interval. So the final answer on this would be that it's decreasing, the speed is decreasing. I guess if you wanted to give them like a full sentence here, you would say the speed is decreasing for the entire interval. So you would say you would go from t is greater than 0. So anytime t is greater than 0, this entire interval, you could write it like that. You could say from 0 to infinity. Either of those would be acceptable intervals right there. And this thing is always decreasing because the signs are always different. And that's your justification. When they ask you to justify your answer, having this number line down here and showing them that the signs are always different, that's your justification on a problem like this. So really we had two problems here. The first part of this was to find out our acceleration equation, which was just doing a quickie little derivative process. And then we wanted to figure out when is the speed decreasing. So we needed to check when are the signs different between our velocity and our acceleration graphs. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.